A linear function is any function that can be written in the form f of x equals mx plus b. Now, that means that it may not be initially written in that form, but if we could make it be that form, then it's considered a linear function. And the thing that's important about it really has to do with this x, that we have an x, or maybe we don't even have an x and we just have a number. Technically that's still a linear function, but this x is not to the second power, it's not to the third power, it's to the first power, which is why there's no exponent, because x to the first and x are the same thing. These functions are straight lines. That's what linear means. If m equals 0, so if m equals 0, that would take out the mx part and we just have a b. That function is a constant function. The m in our formula represents the slope or the steepness of our line, and the b represents the y-intercept. You've probably, at some point in your high school math, you've seen slope-intercept form before. You might also see it where instead of an f of x, we have a y here. And in general, f of x and y are basically the same thing, where you could switch them out and still be talking about the same thing. So let's look at an example where we're trying to figure out from a table of values if we have a linear function or not. And it actually walks us through the steps for that, because a linear function, the neat thing about it is that our x's are changing by the same amount each time and our y's are changing by the same amount each time. They don't have to be changing the same, like the x change and the y change can be different, but for your x's, each time it needs to change. So let's look at this first one. We have -2, -1, 0, 1, and 2. So each time our x is going up 1, right? We're actually just kind of counting here. So if we're going up 1 each time, then for part A, yes, the change in our inputs is the same. For part B, here, from here to here, we would subtract 3 to get from 4 to 1. From here to here, we have to subtract 1, so we already can see that that change is not the same. So that's a no. If either of these are no, or if both of them are no, or whatever, that means our function is not linear. So part C, no, our function's not linear. For part C, not part C, for our second table now, if we look at our x's, well, I would add 2 to get from -2 to 0, and then I would add 2 again, add 2 again, add 2 again. So yes, our inputs change by the same amount each time. Here I would look at the y's, and it looks like each time we are subtracting by 3, and so we're subtracting our y values by the same each time, so that's a yes. And because both of those are yeses, we do have a linear function. It doesn't matter that one of them we're adding 2 on the left side, we're adding 2 on the right side, we're subtracting 3. All that matters is in that column we're doing the same thing. So that one is a linear function.